Okay, we'll be continuing on this. And what we have next is sampling methods. Yes. Now we talked about data collection. How do you collect your data? So we want to look at a practical way of doing this. And like I told us from the beginning, this is an introductory class. And in this introductory class, we'll just be touching on what these concepts are. Then once we get to the real tools, the usage, we'll now discuss in detail what we've learned here. So the sampling methods we have now, you have to understand that there is a population, then the sample we want to work on. And population is the entire group of individuals, objects, or events that share a common characteristic. And a sample is a subset of that population selected for observation, study, or analysis. So in a population, you can now bring out your sample. Then the different kind of sampling methods that we have are: one, simple random sampling. Just as the name implies, it's simple, randomly, and you pick anyhow you want. And this entails that every individual in the population has an equal chance of being selected. However, the challenges it faces are it may not represent specific subgroup well. For example, maybe there is a minority group or a minority subgroup there that are not much. So the chances of picking them up may be less. Then, when to use them when you have an homogeneous population. That is, like I said, the disadvantage when you have a smaller group or subgroup, it disadvantages them. But once you have a homogeneous population, that is all the sets or all the group there, all the data sets you're having are homogeneous, that is they are almost the same, you can use them. Then the advantages is that it is unbiased, easy to implement, and it ensures fairness. Then the next one we have is the stratified sampling. Now, population divided into distinct subgroups based on characteristics. That is, you stratify them, you group them based on a specific or a distinct characteristics. And the advantage is that it ensures representation of each subgroup, increase and also increase precision. Now, what this is telling us is this: you have maybe the top, the middle, and the lower. You group them such ways so that all of these are touched effectively. That is, it ensures uniform representation. Then, when to use them when you have diverse population, as I've already mentioned, and when you are comparing between subgroups. Then the challenge is that it requires knowledge of population characteristics. For example, you need to know, or what that means is that you need to know what your population is. You need to know how your population is characterized. Then the next one we have is the systematic sampling. Now, when do you use this? This is used for the selection of the nth item from the population after a random selection. Now you selected, then you want to pick a very particular one from that sample that you've selected, that you've picked from the population. And when to use, you use when you want to predict or sequential population organization. The challenge is that it is susceptible to periodicity and potential bias. Then the advantage is that it is simple, easy to implement, suitable for large population. Then we have the cluster sampling. Population divided into clusters or group, that is little clusters. You group them into little subgroups. Then the advantage is that it is cost effective, efficient for geographical dispersed population. For example, you can group people from so and so geographical location together and you sample there, then you pick one or two from there and all that. But the challenge is this: the precision is not reliable. Then there's variability within cluster. The clusters are not uniform. Then when to use them when you have naturally divided population or geographically dispersed, for example, IDPs and other, or geographical locations of different places. So if you are working with an environmental based organization, yes, you can use cluster sampling for that. It is your work for you and it is effective. Then we have the convenience sampling. This is selection based on accessibility and availability. That is, who comes first? takes it all. That is all what it means. As it is convenient for me, that is how I select, or that is our sample. The challenge is that it does not represent the entire population. It does not give a true value of the entire population, and it's risky. So, and when to use when you have difficulty to obtain representative sample. Advantage, it is quick, easy, cost effective, but it's not efficient. Yes, well, in its own way it might be in some cases. Then we have the snowball sampling. When you are recruiting participants through existing study participants, that is, you already have people, and in them, you want to still recruit from them. And the advantage is you are reaching hard to reach populations. For example, in a situation where you can't really meet, go down to the nucleus of what you are finding, yes, you can use this snowball um, sampling. And when to use when it is difficult to access or identify the population. Like I've said, you want to get down to that, down base, the nucleus, the actual specific population where it is difficult. Yes, you can use them. And the challenge it poses that it is a biased sample and over representation of a certain group of people, because this is not the true sample of those you want. Then in conclusion, each method, like I rightly said, has their strength and they have their limitations. Choose the right sampling method based on research objectives and population.